Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P16BB, which indicates a problem with the Alternator B Terminal Circuit that has low voltage. This issue can lead to inefficient vehicle performance and may affect your Honda Pilot's electrical system. The alternator plays a vital role, converting mechanical energy into electrical energy, which powers various systems in the car and charges the battery. If your vehicle's alternator is not functioning correctly, you may experience a range of electrical issues. The P16BB code suggests that there may be a low voltage issue detected at the B terminal of the alternator. In this guide, we will cover the problem's specifics, potential causes, symptoms you may notice, and detailed troubleshooting steps to diagnose and rectify the situation. DTC P16BB signifies a low voltage issue detected in the Alternator B Terminal Circuit of your Honda Pilot. This diagnostic trouble code indicates that there might be inadequate electrical voltage from the alternator, specifically through the B terminal. The alternator is crucial as it keeps the vehicle's battery charged and supplies power to the vehicle's electronic systems while driving. Located in the engine bay, the alternator has terminals connected to the vehicle's electrical system, enabling it to perform its function efficiently. A low voltage condition at the B terminal can hinder the alternator's performance, potentially leading to battery drain or electronic component failures. It's essential to address this issue promptly to maintain optimal vehicle performance and prevent further complications. The triggers for DTC P16BB can vary, but the following are identified in the diagnostic process. Firstly, poor connections may occur at the alternator or the underhood fuse relay box. Such faults can restrict electrical flow and lead to low voltage conditions. Secondly, loose terminals can create intermittent electrical contact, causing confusion within the vehicle's electrical system and leading to a diagnostic trouble code. Moreover, an open wire issue in the +B line that connects the alternator to the underhood fuse relay box can also cause the low voltage condition reported by this code. Identifying these issues accurately is the first step to resolving the low voltage problems effectively and restoring electrical integrity within the system. Symptoms indicating the occurrence of DTC P16BB can manifest in several ways. One of the most noticeable signs is the battery warning light illuminating on the dashboard, signaling potential issues with the alternator or battery. Additionally, you may notice unexplained electrical component failures. Items like power windows, headlights, or infotainment systems may not function properly if the alternator isn't supplying sufficient voltage. Also, passengers may experience diminished engine performance, which can exhibit as stalling or sluggish acceleration. If these symptoms are present, it is crucial to follow a systematic troubleshooting process to identify the root cause of the low voltage issues indicated by DTC P16BB. The first step in addressing DTC P16BB involves a thorough verification of the problem. Begin by turning the vehicle's ignition to the on mode, which activates the electrical systems without starting the engine. Following this, clear the DTC using the Honda Diagnostic System, HDS, which will reset your vehicle's diagnostic monitoring. After clearing the code, start the engine to initiate normal operation. During this stage, it's vital to test under specific conditions. Ensure the air conditioning is turned on. Temperature control is set to the maximum cool. The blower fan is at maximum speed. Headlights are on high beam, and the rear window defogger is activated. While holding the engine speed at 2,000 revolutions per minute, RPM, without any load, the vehicle in park or neutral for 1 minute. Check for any confirmed or pending DTCs, using the HDS. In this second troubleshooting step, focus on checking the +B terminal connections. Inspect for any poor connections or loose terminals at both the alternator and the underhood fuse relay box. The alternator connects to the vehicle's electrical system, and any faults at these points can lead to improper voltage readings and the activation of DTC P16BB. This step is vital, as ensuring solid connections here can resolve the low voltage issue if found to be faulty. If the connections are assessed and confirmed to be okay, you can proceed to the next step. However, if you find any repairs necessary, rectify the loose or poor connections and then retest the vehicle systems to verify if the problem persists. The third troubleshooting step involves checking the wiring that carries the current from the alternator to the underhood fuse relay box. Specifically, you're looking for an open in the wire of the +B line within the engine wiring harness. This wiring is essential for transferring electrical energy produced by the alternator to the vehicle's electrical systems and battery. If you confirm that the harness is in good condition, then replacing the alternator is necessary, as the issue likely lies within its internal components. However, if an open wire is detected, proceed to repair the specific section of the +B wire leading to the underhood fuse relay box. Once repairs are made, retest the vehicle before final validation. After conducting the necessary repairs based on the previous troubleshooting steps, it's vital to perform a final verification of the repairs made to address DTC P16BB. Begin by testing all vehicle electrical systems to ensure that they are operating correctly and that power is consistently supplied without fluctuations. It is important to check that the DTC has been successfully cleared from the vehicle's memory using the HDS. Additionally, monitor the voltage output at the alternator to ensure it meets manufacturer specifications and confirms that it can sustain appropriate levels under various loads. If all systems show stable output and the DTC remains clear, then the repair is deemed successful. Document all findings and repairs for future reference. Preventive maintenance is crucial in avoiding the recurrence of DTC P16BB and ensuring the long-term health of your Honda Pilot's electrical system. Make it a routine to inspect the wiring harness for signs of wear, fraying, or corrosion, as even minor damage can lead to significant problems down the line. Additionally, check the alternator's operation regularly, ensuring it maintains proper voltage output and displays no unusual wear that may indicate an impending failure. Maintaining the battery's health is equally important, ensuring that its charge capacity remains optimal and connections are clean and tight. By being proactive with these maintenance tasks, you can help diminish further complications associated with electrical faults and prolong the life of your vehicle's components. In conclusion, addressing DTC P16BB efficiently hinges on identifying the root causes of low voltage in the Alternator B Terminal Circuit. Following a systematic approach throughout each troubleshooting step ensures that all aspects of the issue are carefully evaluated and considerations are made regarding connections, wiring, and the alternator itself. It's equally vital to carry out regular maintenance checks to catch any potential issues before they escalate. By staying diligent with inspections and addressing any concerns promptly, you will not only resolve DTC P16BB effectively, but also enhance the overall reliability and performance of your Honda Pilot. This guide serves as a comprehensive tool to assist you in navigating these challenges and ensuring that your vehicle remains in prime condition. Please like and subscribe to the channel. See you next time.